In this video, we are going to discuss drying process. Drying process, spray dry, drum dry and vacuum dry, and the comparison, how we get fine powder, coarse powder, granules. Powder we are getting dry ginger powder, onion powder, carrot powder, almost all the things are available in powder form. Not to speak of milk powder and coffee powder. Milk powder and coffee powder are most common, but nowadays we are also getting carrot powder, ginger powder, onion powder. So how do we get powders and why some of them are fine, ultra fine, while some of them are coarse and some of them are granules? What is the method by which we can get powders, dry powders, that would be fine or coarse or granules? We compare spray drying, drum drying and vacuum drying. So in this video, the drying process and comparison among the three commonly used processes of drying. First, we will take up spray drying. Spray drying usually results in fine powder. You can see on the top, we have given coarse coffee powder and fine coffee powder. Spray drying usually results in fine powder. It is mostly used to get milk powder. Milk powder. Spray drying is usually used to get very fine powder like milk powder. The concentrated solution, for example, dense coffee liquor or concentrated milk, is sprayed as a mist from the top using an atomizer. So you're getting a mist, something like when you spray some perfume, that perfume comes in the form of mist. So it is even finer in the form of fine mist because you are using an atomizer and this is coming from the top. A current of hot and dry air moves upward. So the feed is coming down and hot and dry air is going up. They are moving in opposite direction. The fine mist using an atomizer that is coming down and the hot dry air current is moving up. The dried products are collected at the bottom. So dry particles will fall at the bottom. They will instantly dry as the feed using an atomizer in the form of fine mist is coming down and hot and dry air is going up. This is called counter current principle because the two things are moving in opposite direction. Now, why is it important for school students? See, the two principles here, the two important principles here are actually what you learn in school. What a schoolboy learns in, say, class 8 or 9 or 10, right? The two important principles. It is taught in schools, middle school or high school level. First is how to get dry air. So we get dry air by removing moisture when we pass air through calcium chloride. When air is passed through calcium chloride, we get dry air. That is how we are removing the moisture and getting dry air. Counter current principle. The concentrated spray of feed and the hot dry air travel in opposite direction. This is seen in many cases like in fish, where blood flow and water flow are in opposite direction in the gills for maximum oxygen exchange. You can see we have given the picture of gills of a fish. The water flows in opposite direction, the blood flows in opposite direction. They don't flow in the same direction, right? The blood and the water will flow in opposite direction. Counter current principle. So counter current principle is something you study in biology, is something you study in physics, is something you study in chemistry. The two things should move in opposite direction for best and optimum exchange. And removing moisture is passing air through calcium chloride. So these are basically principles that you have studied in schools. That's why it is important to know that science is not in textbook. Science is all around you. Science is what you see in daily life, and science is not confined to what you read in textbooks. So here, the hot and dry air by passing through calcium chloride and counter current principle, both should move in opposite direction for maximum exchange. So now we come to vacuum drying usually results in slightly coarser particles, mainly used for salt. Mainly it is used for salt. When you get the salt packets, cooking salt, table salt or cooking salt, mainly that's made by vacuum drying because you get slightly coarser particles. Although fine powder may be compressed into larger granules. We see this used mainly in salt. It is sometimes written vacuum evaporated. That is the same as saying vacuum drying. Vacuum drying and vacuum evaporated are same thing. So vacuum drying or vacuum evaporated, they are synonymous, and vacuum drying will give you not so fine instant coffee powder. If coffee powder is made by vacuum drying, then you won't get very fine powder. You'll get slightly coarser, not so fine, slightly granular, small granules. But if you want large granules, then we have to compress using physical pressure. The smaller granules can be compressed into larger granules, but if coffee powder is made by vacuum drying, it will be not so fine coffee powder. It is mainly used in salt. A highly concentrated solution placed in near total vacuum will cause water to evaporate instantly. What you are doing? You are placing a highly concentrated solution, brine, in vacuum. When they are placed under vacuum, they immediately evaporate. The water immediately evaporates and gives microcrystals or small coarse particles. The brine is kept under vacuum or near total vacuum. So immediate evaporation of water giving you crystals or small coarse particles of salt or coffee powder. So this is vacuum drying giving you not so fine particles. May be used in coffee but may also be used, or it is mainly used in making salt. Now again, why it's important for school students? This is the basic principle taught in physics. In physics, in middle school, you learn this. Rate of evaporation depends upon the pressure over the surface of the water. The air pressure over the surface of the water, that determines the rate of evaporation. Low pressure, faster evaporation. So, if a very low pressure is created above the water surface, the evaporation will be very rapid. Salt packets labeled vacuum evaporator are made in this process, vacuum drying. So we have shown a glass of water or a glass half filled with water. Now if you place it outside, the pressure acting on it is the atmospheric pressure. So it will take a long time to dry. But if it is placed under a bell jar and made vacuum, then it's near total vacuum, very low pressure, then the evaporation will be very fast. So if you create a vacuum, you get a very fast, in fact instantaneous evaporation of all the water, and that's what exactly we are doing in vacuum drying. Place it under vacuum so that water evaporates instantly, giving you coarse particles or small granules or microcrystals. So this is the principle of physics that rate of evaporation will depend on the superincumbent pressure. If the pressure is large, like atmospheric pressure, you keep it in the open, evaporation is low, but if you keep it in vacuum, the evaporation will be very fast. This is the principle we are using in vacuum drying. The third one is drum drying. We are not discussing here because this is obsolete. The drum drying process, we have given the diagram, but the process is obsolete primarily due to product quality issues especially for heat sensitive materials and operational limitations. So the drum drying process is almost obsolete. Maybe we will come with another video about drum drying and why it's obsolete. We may discuss in a different video why it's obsolete if there is a request. If a request comes, we'll make a video why drum drying is obsolete. But now, drum drying is obsolete mainly due to product quality issues and operational limitations. So drum drying is not used nowadays. So that was the video how we get everything dry and why some of them are coarse and some of them are fine. If they are made by spray drying, then they will be very fine. But if they are made by vacuum drying, they will be not so fine. And then, of course, you can press the smaller particles together to form large granules. So, the process of drying and the important principles, the important laws of science which are taught in middle school. So, it's important for school students. See the principles which you are learning, how they are applied in practical industry. These are simple elementary principles, but you can see the products in everyday the industries are applying the very same principles. So we shall come back with more interesting videos. Till then, thank you and goodbye.